Kitchen Table Astronomy with Hampshire College astronomer Dr. Salman Hameed, Mr. Universe here in Amherst. Big news today is the release of the names of the astronauts on the Artemis mission to the moon. But full disclosure, that is happening after we're chatting. So, with the miracle of digital editing, here's they are!
I can't believe you gave away that. We could have just said, what an amazing information. We're going to talk about it next week when we have, a little bit more information about it.
We get to know them a little bit.
That's
better.
exactly right. But
we should see what our favorite friend, astronaut from Shelburne, Katie Coleman, thinks about the crew.
That's exactly right. No, I think it's a big news. And we will talk about it later.
The other big news is the James Webb Space Telescope, which launched a year ago-ish now, getting close to it, and the largest infrared telescope in the universe that we know of. And it's been spending time looking at a particularly interesting spot.
Right. So actually, it's been over a year for
really?
James Webb Space Telescope. That was December of 21. Although with the pandemic, it's all confusing now. So who knows? But the first results from James Webb Space Telescope were released in July of last year. Mm-hmm. So that is true. But one of the objects that everybody was waiting for was to look at Trappist 1 system. And
is it filled with monks who brew beer?
That is exactly what I was thinking about. No, that is actually cool. We can talk about monks, we can talk about beer, but no. But this system is still really crucial, and the reason is because it has 7 Earth-sized planets orbiting this star.
How many does our solar system have? 1? Or does Mars count as an Earth-sized
planet?
Well,
if you talk about sort of like rocky planets, then certainly Mercury, Venus, Earth, and Mars. And interesting planets, no offense to Mercury, but interesting planets would be Venus, Earth, and Mars because they are close to the habitable zone, and life could have and did in one case certainly did emerge. And so having rocky planets, small rocky planets is a really big deal. Mm-hmm. And this particular star is not like the Sun. So Trappist 1 is much smaller than our Sun. It's called a red dwarf, if you want to call that. But it's much cooler than our Sun. But these type of stars are much more abundant in the universe, mm-hmm. and they live much longer lives. And so this is interesting, and we think that these type of, like Trappist 1 type, small red stars, they contain more terrestrial planets, more Earth-like planets than a star like our Sun. And so I'm just setting the stage up. As you can tell, we may not have that exciting news about the actual planets. I'm setting the stage up of why this system is so important to study. And this star was discovered, I think, in the 1990s. And Trappist actually is a telescope. There are 2 telescopes, one in the southern hemisphere in Chile. It's a robotic telescope. And then there is another one in the Atlas Mountains in Morocco. So, and actually, I should mention, because astronomers are terrible at naming things.
Oh, yeah. You guys are really
very large array, really, really large array. Well, I don't know if that is the case.
That's why you kind of name the telescopes. The fact that the James Webb Space Telescope, despite the problematic nature of the life and legacy of James Webb, at least has a name that people can remember.
Right. So this particular one, Trappist, it's actually Transiting Planets and Planetesimal Small Telescope. So it's kind of cool, and it's Belgian, so hence the Trappist connection that comes in, and these are like 24-inch telescopes, but they're robotic, and that's how this star was discovered in 1999, but then astronomers detected planets orbiting around it, and not just 1, but 7, mm-hmm. And astronomers named these. So the first planet detected around a star, it's given a designation of small b. And so Trappist 1b is the first one discovered. So it has B, C, D, E, F, G, H, and they are actually in order. So B is the closest one, and then C, D, E. As it turns out, this is an unusually compact system. So all of these planets fit way within the orbit of Mercury for our sun.
Wow. So if all of our planets in our solar system were between the sun and Mercury, this is like this Trappist system we're looking at right now.
Much more closer. In fact, the closest one, so which is Trappist 1b, that takes only 1.5 Earth days to go around its star. And the farthest one takes 19 days.
So that's a year. The farthest,
That-
the
for
longest
that,
year
yes.
in that solar system is 19 days.
And for Mercury, it takes 88 Earth days. So already, so you can see it's a very compact system, but the star is much cooler. So despite of that, there are at least 3 of these planets, which are D, E, and F, which we think they are in the habitable zone, meaning to say that they are far enough from the star that, in theory, water can exist in liquid form.
Sometimes they call it the Goldilocks zone. Not too hot, not too cold, just right. With all of this mythology and fairy tales, I mean, it's a red dwarf star. There are 7 little, planets around it. It feels like we're talking about Snow White here.
That's right. I think this planet should be named Disney.
Well, soon enough, Disney will own it.
That's right. So, that's one of the reasons why James Webb Space Telescope, because it can potentially detect atmospheres around it. And if you can detect atmosphere, you can figure out, for example, if there is oxygen in the atmosphere or not. And on Earth, the oxygen here, molecular oxygen in the atmosphere, was actually a result of life. And so that is sort of like one of the indirect signatures that you can detect. And so Hubble Space Telescope, and there was another space telescope, Spitzer Space Telescope, they tried pushing their limits and tried to see atmospheres, and they didn't see it. But the problem was they were really pushing their limits. James Webb Space Telescope is designed to look for these things, and they have been looking at this particular system. And so far, astronomers have released the results of only Trappist 1b, which is the closest one, 1.5 days. It takes 1.5 days to go. It's not in the habitable zone. And the results are, drum roll please, Monty. There you go. No atmosphere.
Oh, dang it.
Okay, but look, there are a couple of things that I want to say regarding that. First of all, it is amazing that we can actually detect sort of like whether there is an atmosphere or not. Because the planet in this case is reflecting light, and it's reflecting light in the infrared. And James Webb Space Telescope is designed to look at that, and it can figure out how hot this planet that is orbiting around Trappist 1, which is actually, by the way, 40 light years away. So relatively close, but still quite far, and it's a very small star and a small planet around it. And they can figure out what temperature there is. And it turns out it's too hot, which would be expected. Nevertheless, they did not see any atmosphere around Trappist 1b. Now, we know other planets in this system have been observed, but they haven't given us the information. Maybe it's going to be sequels, like, next year, Trappist 1c and 1d. But
I just watched John Wick 4, and I was like, wow, yeah.
Did he have an atmosphere?
He did.
Okay.
Keanu always has
aura.
an atmosphere.
Yeah, there you go. So right now, it's a good test of technology to a certain degree. We got a lot of information, and this is the first time actually that we have really gotten good information about an Earth-sized planet in terms of the atmosphere. If you remember, one of the first results from James Webb Space Telescope was an atmosphere around WASP 39b. And so that was a very hot star. I mean, that was a very hot planet, and I think it was around a sun-like star. But that was expected to be very hot planet, no life in there. But there was an atmosphere around it, and it detected that. Here is a case that we are actually looking at a system which, first of all, is much more common, and secondly, that James Webb Space Telescope can actually give you information about what is happening to a certain degree on the planet, even if this result is negative. Remember, the really interesting ones are D, E, and F, which are the 3 other planets that are in the habitable zone. Maybe another one, maybe G is also, C is also, there may be another one also in the habitable zone, but certainly these are the ones that we'll be looking for.
So we can skip the results of C. We'll just assume. Forget it. We want to hear what's DEF. A Def Comedy Jam, Def Leppard. That's where the life could be in this Trappist one.
Right, but we are in Fabulous 413.
Yeah.
And I would like that to have sort of like, a really fabulous skepticism.
Uh-huh.
And I know I'm going to be beating a dead horse regarding this, but I wanted to bring this up. Just look at how carefully astronomers are looking for. They're not like, hey, we really want to believe, we really think that the Trappist one has life. But look how carefully astronomers are going through. They are making sure, that they rule out all other ways that can these results be explained otherwise. And in this particular case, for example, if there is no atmosphere, there is no atmosphere. I'm a little sad. But hey, if it comes out that the other habitable zone planets don't have atmosphere, yeah, there'll be a little sadness in it. But then that is the way it is. Compare that, where I'm going with that, about the UFOs.
Yeah.
Right? I mean, oh my goodness, we cannot explain these things, but not just that those are things that we don't know what those are, but rather those are spaceships flying from somewhere else, and so on and so forth. So this just gives you, again, one more time, an idea of how science works in general, or good science works, and some of the big claims that often turn out to be wrong, and we don't have. So Fabulous 413, fabulous skepticism.